Welcome again. I'm going to continue with this Essential Mathematics Computational Design 4th edition by Raya Isa. Hope I'm saying the name right. Basically getting me to practice Python as much as I can with Grasshopper and start to build some snippets that I can use single nodes. It's a great handout. It's free online. When you go into it, you can always get those Essential Mathematics 4th edition, and you can actually go so far as to download all of the files that they have, which are absolutely amazing. And if you look here on my far right, you can see how complicated it is. It looks 10 times worse than the files that I build. But you can go in and learn how to script in Grasshopper, all of the basic maths, and come to understand it. And they're going to show you how to do pretty much everything. But the best thing about it is as you run through it, they will purposely move past defining all of the vectors, the matrices, and then onto surface and NURBS curves. So it's going to get complex real fast. But when they have a half-decent little script, they're going to bring that all into GH solution for you right here, which is very easy to throw together. Then they're going to show you how to write VB script, C# script, which I am not interested in. There is the Python with Rhino common only script. I've been using this with Python with Rhino Script syntax, and sometimes they only offer this one up, which is kind of an import Rhino. This one will allow you to import Rhino Script syntax. So you kind of got to see what they have to offer. That said, I don't think it's about knowing where to find it. I think you got to walk through these things and find out if you actually have, can wrap your head around what's going on. So if I jump into here and go into this script, I'll go back to mine, and I will make a fairly small script, which is pretty simple. I'll make my own boxes, which is what I do here. I go in, I build a box. I have it set up that the Python node is called box and distance, and I've made that all parametric, so the size of that box on XYZ is also the extrusion distance, just to keep it simple. And then I threw on a geometry instead of just this param viewer to see the 6 sides that come out of it. The main thing is let's go into the script and see what's written there. So when you double click on one of these, obviously you have to go in, you have to right click, you have to change box to, you can put in as many inputs and outputs as you want. This is what's to print if you send to print, but otherwise this is the information that's coming out as an output. But you have to change your box is what you're going to be using it as a variable. You got to change it to box and distance there. You got to use that as distance. And you can do that by right-clicking, changing here, and just exiting. You can add and subtract things as you need them. That said, I'm going to jump in solely into the Python script and maybe make it a little, well, I'll just leave it at the size it is. Well, let me see if I can make it, well, no, I'm not making it any bigger. Anyway, let's take a look into it. The script is pretty simple. In this case, they're importing Rhino. They're not importing Rhino script syntax as RS. So you've got to type Rhino to all of this stuff, but it still works as you go in. I have a little bit of difficulty with so you could always go in here and just grab this script and jump right into the Python and go and cut and paste that script. And that's one thing to do, but you're not going to learn anything. You're going to learn where to get it and how to do a box extrusion. No big deal. You can find that on GitHub. You can borrow that from anybody. So what I would suggest is going in, getting back out of that. Hang on, I kind of buried it here. Made it so small I couldn't get back out of my script. Go back into the one you're dealing with. Pull up your script. Have it on your sides. And take a look at what you have to type in exactly. You have to type in Rhino script, and you're going to get the rep center. So that's pretty simple. You're going to define a variable area, go to Rhino, and as you start to type Rhino and hit dot, geometry will come up when you start typing G, area mass properties, compute, box, and you're going to find that's very similar to right down here, area, because you're going to compute the center of each face. So Rhino, geometry, area mass properties, compute, extract face, because that's the variable that you're actually going to see comes in later. But these two things are very similar, just like box center equals area dot centroid. You're going to have center of each face be area dot centroid. So you're going to see that repeat in its code. Then you get the list of faces. So you basically build a list. Faces equals box faces, and you're going to call that exploded faces and put that into a blank list. Then you're going to do an iteration through each of the faces using the enumerate function of the faces for I. And you're going to call a variable, extract, and make sure you have the indent, because it's all about getting the proper indentation in your functions as you go through for the for loop. And in enumerate faces, I is there, so you will extract faces as a variable, faces dot extract face at I, and that will move through I 1, 2, 3, 4, 5, 6, or 0, 1, 2, 3, 4, 5, whatever its index number is. Then you have your area, Rhino geometry, and that's what I said. It's very repetitive to what you did at the top. Now you're going to find the area of each of those faces, and you're going to find the centroid of each of those faces. Then you're going to calculate and move the direction of those centroids to face center. So that's the same type of vector understanding of finding a direction by one variable minus another one. So center minus box center. Then you're going to unitize that. So you just bring it to one unit. So you will have to put in an amplification factor to see later what you want to do, and they've got this fun little function that is basically direction equals direction times distance. So you're basically you can do a short form by just times equal, and then put the distance in there and run that command. Then you're going to move and extract the face. Move equals Rhino geometry transform dot translation of the direction, which is the variable which was being defined by the distance from the unitized vector, and then you're going to add the exploded faces to the list. So you're basically appending what you had in extracted faces being what the extracted faces were originally, and then you're going to simply append that with the extracted face every time it goes through, and A will be those exploded faces. That's a nice little script. You don't have to memorize it all. You have to kind of run through it, read it in kind of pseudocode or English, or read it in these little if you didn't like the hashtag's a good way. I think you could actually just practice for one thing. I always want to know. I think you can grab everything and just hit, I think it's Control / or not to put all comments on, and then take them all off with Shift. Maybe I shouldn't even mess with that right now. You run the test. If the test works, it should be fine. You can close out. You can hit OK to close out. You basically have all that script that was written in there and the other code written into this one node. You can change the boxes. And you should be fine. And depending on changing the parameters of this, could be interesting to see how you can explode faces with different geometries. That's enough said. I just wanted to walk through it for 7 minutes. It's making sense to me. I popped it in here, so I have one version of it here grouped. And if I ever wanted to grab it again, I go to my snippet tools. I find my Python script snippets, and there's my explode box, bring it in, and boom, I have a second one there that I can move around and do whatever and play with that and change it and start to manipulate another one in and around that one. Pretty interesting stuff. I like it. I think it's the way that I kind of learn. Knowing where the data is one thing, but knowing how it kind of plays out. Like I said, you can find they'll provide an awful lot of information for you to search and learn. But this is the type of scripts that I end up making for myself, and I've done that on this online resource as Grasshopper for Rhino, the ABCs 1, 2, 3s. And I definitely think this is the way to go about learning and keeping advancing your skills. I've already run through out of the 100 pages. I think I'm on 33, and we finished up for the essential mathematics. We're going to go into tangent spheres next and make some pretty cool tangent spheres and put it into Python script. If I get good at this and I enjoy it, I may go into C#. I don't know if I'll go into VB scripts. It's up to you to learn it. I've had no demand to do it. I'm doing this all on my own, and because of my mathematical mind and where I came from, I find this incredibly interesting. Plus, I think this is just fun as anything. So, all right. Thank you very much.